Alvaro. So here you have it, guys, from Anish and from Alvaro. It's clear that working in desert locations, it's like the toughest of conditions. So if you're good in desert locations, you're probably good everywhere else. We're going to hit in more detail. And of course, you guys, I mean, we're responsible adults, professionals. We're not going to be here in front of you for an hour if we haven't prepared something. We have prepared a little structure, we have some questions that we've discussed, but that is not the point of the session. The point of the session, of course, is to give really good content, that you guys can use in your day-to-day work. But most importantly, the point is that you can ask the questions that you have directly to these two experts that, let's be honest, not that easy to get hold of and have access to. So please use this opportunity. And here's how you do that. You send your questions through the Q&A box at the bottom of the screen. I know that there are some people here with us in Zoom, but there are also some people in YouTube, and there are also some people in Mayata. We have distributed folks here today. We make it easy for you so that you can join through whatever platform you want. So please, whatever platform you send your questions to, we have someone there, Valeria, my colleague, who is going to be taking the questions and sending them on so that I have them. Okay, so please send them on and we will consider them. If we can answer them right away, we will. Otherwise, we'll keep them for a little bit later. If you guys send me 50 questions in the last 5 minutes, we're not going to be able to manage. So the sooner you send them, the better, really. And just, you guys are being quite shy today. I can see only 3 or 4 people introduce themselves. Come on, keep it going. And welcome to the people from Tunisia, people from Tanzania. Okay, we have here simply Middle East, good enough. People in India. So welcome, and please keep introducing yourselves. We always like to hear where you're coming from. And I think it's clear that the lessons learned in the Middle East can help a lot of people. But still, okay, so let me throw the first question, you guys, and I'm going to let it open to the two of you, whomever wants to start, okay? And by all means, also speak amongst yourselves. And we'll keep keeping an eye on all of those questions from the audience, okay? So first question, Manish, Alvaro, which are the main environmental challenges you encountered when developing PV projects in desert locations? So who wants to start? We're warming up only.
So,
Go right ahead, Manish. Yeah.
If you want, I can start.
Alvaro, you start and then I'll complement.
Sure. So, I mean, basically on tracking systems, the most critical aspects that you have to tackle when designing for desert conditions would be the wind speed. I mean, probably in desert conditions, you would have the same restrictions as in any other region, but specifically would be wind speed and sudden wind gust that might happen in desert conditions. Abrasion, which is quite critical. I mean, it's only a matter of corrosion because on desert, when you have a plain desert, the sand that would be hitting on the tracking system would be damaging or eroding the surface of the tracking system. So the corrosion rate would increase. It's a critical factor, and it's really important that you don't only focus on the corrosion of the tracking system, but also on the abrasion. Also, quite critical factor is the maintenance of the site, and it has a big impact. What's the layout that you design on your site? Now we're seeing a big trend on desert conditions that they are EPCs developers are trying to integrate robotic cleaning solutions. The shape has a great impact on the amount of robotic cleaning solutions that you need to implement on your site. And lastly, the foundations on desert conditions. There's a lot of sand on desert, of course, but then below that sand, you usually find a hard layer of rock. Depends on the region, it can be shallower or deeper, and it has a great impact on what's going to be the installation works. Concreting in desert conditions is really expensive, so it's a critical factor to understand what would be the foundations that you need on these sites. So probably, Manish, you'll have a better understanding of what those costs would mean on the actual project itself. Those are the main parameters, at least on the tracking system side.
Thanks, Alvaro. You touched some of the very important pointers. Just to complement to your thoughts on the corrosion and abrasion, the ground corrosion also plays a very important role. And as per our experience, in many areas, the ground corrosive nature is extremely high. And you don't have any specific code or standard which will allow you to understand how the system needs to be designed, and we still continue to rely on the ERT test and the ground chloride concentration. That's to complement to your thoughts. The second challenge that we have observed is high level of soiling losses in all these areas because it's a sandy sand dunes all across. So it results in additional cost because the labor is extremely high, and we are now switching to robotic technology on almost all our PV assets. But robotic also is a very nascent and is getting matured as people are getting experienced. So there are certain challenges in terms of the performance evaluation and monitoring of the effectiveness of robotic cleaning. And Alvaro rightly mentioned that layout plays a very important role, how you design it in order to optimize the number of robots. Third thing which I would like to add is, while many people believe that desert areas do not see much of a rainfall, we have observed that rainfall, while they are erratic, but the intensity is extremely high. And if some of your locations are undulated and they fall under wadi areas, a lot of geotechnical work are required, and you need to be very cautious while designing the plant. This is a bit from my side. Dalan, over to you.
Thank you very much. Very interesting points. You seem to agree on the abrasion and the corrosion, but it seems like clever design is the only way to really overcome ultimately the long-term challenges. I found that really interesting. And rains, I wouldn't have thought that I would hear about rains, but honestly, I lived in London for 14 years myself, and the rain stopped everything in London, and it rains all the time. So I can only imagine that in places where it doesn't rain very much, it creates a lot of havoc when it does rain. What are the security and safety requirements that we need to consider when designing and operating a PV plant in these locations?
Let me take this, Alvaro, and then you complement. I have worked in countries like India and neighboring Asian countries, and as well now in Middle East. I can clearly say that some of the risk which we saw in Indian context or the neighboring context, which is theft of material, that is nowhere seen in Middle East countries. The locations are very remote, and these kind of challenges are not seen. The fans are generally more costly, and they are being regulated by the local bodies. In case of Oman, it is Oman Royal Police. In case of Saudi, it is controlled by HCIS. So from the perspective of fence design, the challenge is it goes through regulatory process. The design is a little bit heavier. But the main safety concern that we have observed is extreme temperature conditions at the site. So when you design your plant, you need to be very cautious with respect to the heat dissipation design of your key equipments, mainly the inverters and the transformer. And sufficient factor of safety need to be inbuilt so that they can sustain higher temperature condition, and more specifically on the duration of your inverters. They are likely to derate more if during the design stage you don't take proper care. And during the construction phase, we ensure that our workers on the ground, they are not allowed to work around the noon time because of the climatic conditions. So these are the safety related facts which I would like to bring before all the participants. Over to you, Alvaro.
That's right. Yeah, I mean, you brought a really good point on at least on the installation. I was thinking on tracking system only in the supply, but then regarding the installation, it makes a great point that you can only perform these installations during nighttime, especially on these conditions, and it's something critical that you need to take into account when designing or executing the project. In terms of the tracking system, there's safety requirements, or at least design requirements specifically for this region. I mean, globally, we always need to design for the conditions that we might find in the project. Desert conditions don't have the critical aspect would be the sand and the abrasion and the corrosion, because places with higher wind speed, of course you have places where you have hurricanes, and those places have more restrictive design requirements on the tracking system. But the most critical one would be the corrosion and abrasion. If you need to design a plan that would last for 25, 30 years, and you need to provide this warranty, and you only take into consideration the corrosion, you would be creating a thickness or designing a tracking system to withstand 4 times less than what's supposed to be designed. So probably in 12 years, your tracking system will be completely corroded, and you start to have issues on the working, on the functioning of the tracking system. So that would be the aspect on which you would need to focus more on tracking system on these environments.
Excellent. Thank you very much. You guys, we've already been receiving a few questions which I'm going to take into consideration. Guys, I've got a note here. They're mostly about soiling and dealing with sand and sandstorms and things of the like. We'll get to that a little bit later. We're going to focus quite a bit on wind. So how to deal with wind side, I'm going to focus on that, and then we'll go to the questions about soiling and all such. So keep going with the questions. What average wind speed values you encountered in Saudi Arabia? Would you recommend doing a site-specific analysis before determining a suitable design? And please explain, because you've been talking a lot about having to design cleverly. So if you could, go into a little bit with this. And Alvaro, you want to start, and then Manish, if you want to add something, go right ahead.
So on terms of wind speed, you could find on this regions wind speed ranging from, I don't know, 44 meters per second, 50 something meters per second. So they are mostly, the wind speed requirements are more or less the same. What the main concern that you might have on the wind speed is that you should always try to perform a site-specific report. Typically, this also happens globally. When you have the wind speed for a specific project, you're taking the measurements from a place nearby or from tabulated data that's not precise. So if your intention is to have a cost-effective solution for your project and to comply and to make sure that it's not going to be blown away, it's better to have always a site-specific assessment. And the differences in wind speed between site-specific assessments and what we've seen in generic data could be on the range of 6 meters per second, 10 meters per second in some cases. So it's always better to have that data.
Manish?
Thanks, Alvaro. Just to add that wind speed in some areas closer to the sea are extremely high, and how in aqua power, how we ensure a robust design under such condition is by having a third-party design consultant who thoroughly reviews the design proposed by the tracker supplier. And we insist on having a wind tunnel study being carried out on a prototype model for both the static and dynamic loads. So, and plus we have in-house experts, structural experts who goes into the details of it. And then the most stringent factors gets applied based on the third-party analysis as well as based on the Saudi building code.
Oops. Excellent. Thank you very much, guys. Let's keep going to the next question, which is also about wind, if I'm not wrong. No, actually, it's more about the climate. So are quality controls carried out on these climatological data sources that you use for the plant?
Yeah, that would be probably the same line that on the previous answer. You always need to have your own assessment done at the site, because you have those deviations from the data that you can find on codes or on close by weather stations. It's better to always have your site assessment. And this wind speed is more critical depending on the tracking system that you will decide to use. And on 1P tracking systems, the effect that you have on the wind might be less, so you don't need to care as much on having this site-specific wind assessment. If you're going to use a 2P tracking system, because the reaction forces that you have on that tracking system would be bigger, it's more important. So it depends on the tracking system that you would use. I would suggest to always do this site-specific assessment. Of course, it has a cost, but depending on the tracking system, it makes sense. And what Manish was saying about this specific analysis, structural analysis, having the wind assessment specific for your tracking system, it's also quite critical. A few years back, there were lots of cases in which we saw that there were problems with tracking system. At that time, it was difficult to understand what was going on, but then doing a full 3D elastic test gave us the answers, and we understood what was the flutter, the torsional galloping, and the issues that the tracking system might have. So, and especially on 2P tracking system, this fraction is bigger. So this assessment, you don't only need to do the assessment on the sites specifically, but also have a proper assessment on the tracking system based on the wind speed that you have at the site.
Alvaro, just to take the attention away from trackers for a moment. On the climatic data, some of our audiences might be exploring Middle East markets. So for their advantage, we all know that there are various sources of data points while shortlisting the TMY file. We have NASA, we have Meteornom, Solar GIS, 3-tier. So what we have observed in this part of the world is the Solar GIS site-specific study reports are very close representative of the actual condition with a minor degree of variations. So we rely mainly upon these. And when it comes to albedo, which is discussed more and more in these days, as almost all the plants are with biofacial technology, so albedo plays a very important role. So on the albedo, again, we have site-specific albedo report from Solar GIS and similar other consultants. In some cases, we also conduct our own on-ground measurements running from 7 days to 15 days to a month, depending upon the impact of it. So that's through these two mechanisms, we have better control and better assessment of the environmental condition. For other parameters related to the soil, we conduct hydrology, very detailed hydrology assessment, as well as geotechnical assessment by professional third parties. And we have a framework by which those parameters come onto the table with close accuracy. And again, on the tracker, Alvaro has confirmed, I spoke earlier, wind tunnel studies are usually carried out, and we don't rely only upon the wind speed mentioned in the SBC code.
Excellent. Thank you very much, guys, for going so much into wind speeds and wind, I suppose designing around the wind environment. Next question is also about wind, but it's very specific. And I think this has been asked several times by the audience. So I'm going to, but there is slightly different, okay? The one that we had is what happens when wind is strongly conditioned by orography. What effect does it have in tracker stability? So we're focusing very much on tracker, but on top of that, people have been asking, what is your vision on tracking system in cyclonic areas, which is very similar, goes around the same topic. And a further question from the audience says, in the case of sand dunes, is it really required to consider soil erosion due to wind in foundation design, being the loose sand prone to be transported from one place to another? So the three of them hint at a very different, like a very same issue, but from different perspectives. So I just wanted to throw them out so that perhaps you can give a little bit more of a contextual answer. So Alvaro, do you want to start with the tracker, and then we can maybe take it up the context a little bit? Yeah.
Okay. I'm seeing that there are a few questions. It's a little bit difficult to track all the questions that are coming in.
Sure, I can say them again because I've written them here. So the first was, what happens when the wind is strongly conditioned by orography? What effect can it have on tracker stability? Then someone asked, what is your vision on the tracking system in cyclonic areas? And then a further question, which was also very similar. Let me just find it, 1 second. In the case of sand dunes, is it really required to consider soil erosion due to wind in the foundation design, being the loose sands prone to be transported to one place to another? So in other words, why did you study so much the orography if it's going to change, right, with the sand moving? So
on the first question, if you need to take into consideration the site topography, you do need to take it into consideration, because well, it really depends on how the tracking system is designed. At least on the case of PVH, we have a strategy that comes from the wind tunnel assessment, and we have external and internal rows. So if you have the topography that it's really undulated, those trackers that are in high hills or really exposed to the wind would need to be reinforced. So would need to be as an external row. But then the same thing happens on the opposite. If you have a concavity at the side and that tracking system is going to be protected from the wind, that tracking system could be considered as non-exposed. Then on the cyclonic areas question, yes, I mean, particularly Middle East is not a region where you see this kind of events, but we have supply tracking system, for example, in Mauritius Island. We have a tracking system that has been working for 5 years. And in essence, what you need to do is design according to the conditions that you have at the site. If you know that you're going to have cyclonic winds at some point, you need to design for the worst case scenario. So you're able to withstand those high winds. And on the foundation, and if you need to design specifically foundations, and if, knowing that the sand is going to move around the site, yes, you take that into consideration when designing the piles. And we know that the topsoil might get eroded or might move. So there's a layer of that sand that is not going to move, or supposedly it's going to stay, and it's only a top layer that might be changing. Or if it's a really big sand dune that is going to completely move and it's going to shift, then you need to design the piles to be able to anchor on the solid strata of the sand. That depends on the project. So for example, on a specific project on Diwa in Dubai, we had really different areas at the site. We have areas in which we had a hard layer of rock or hard sand 1 meter. So on those areas, we would need to design piles that would reach that top layer and then stop there. But then we had other areas where we had sand dunes of 10 meters high. On those areas, we would need to use concreting, so we made sure that the piles wouldn't lose the traction needed on the ground, even though the topsoil would need to move. So we would need to see the specific cases, but there's always a solution, and you can always design to different soil conditions.
Thank you very much, Alvaro. Do you want to take, Manish, the third question, perhaps, about the moving sand?
Yeah, Balan. I think it's a very good question asked. During the geotech investigation, we get to know the exact nature of the soil. And if we believe that the topsoil, 100, 200 mm, is likely to move here and there, then from the strength perspective, from the uplift force perspective, we add that much cushion in the foundation depth. Regarding impact of wind speed on tracker stability, and it's a very good question, very powerful, because many of us, including most of the panelists, must have heard horrifying stories of trackers flying in the air, and that was a few years back when the tracker industry was also learning and improvising their designs. But of late, majority of the design from all the leading players, I would say, they are very safe and robust. They have learned their own lessons and they have significantly improved the designs. Whether it's a cyclonic conditions or a normal condition, I think each tracker is designed for the site-specific requirements, site-specific conditions. I can quote a case from Philippines where I was involved in the past, where the wind conditions are extremely high. They are touching 65 or 70 meter per second, and with frequent cyclones. So the tracker cost goes up. The design of the tracker is more stronger. The members thickness is extremely high. So it's not that these conditions will pose a challenge before you, it's just a cost challenge. So if there are similar conditions that you observe, just be watchful of the cost of your tracker while bidding for various projects.
Thank you very much. Yeah, make sure also that the tracker partner that you have on site is reputable and good quality. You know, that'll be like, I think you get yourself into good hands. So how are the PV structures protected against corrosion and abrasion damage, guys? In particular, because there is a lot of questions about sandstorms and issues with cleaning, but like particularly the fine dust, that ends up in all of the mechanics. So how do you protect your systems against that? You want to start, Manish?
I think let Alvaro start. It's his domain, his expertise.
That's for sure. I
And
just thought,
I'll
like,
be able
because
to
it's the PV
complement him.
system.
Yeah.
I mean, mainly Alvaro is the tracker, right? That's what we need to get right. So how do you do it?
So, I mean, on the sand, I mean, it's not only going to affect, or abrasion and corrosion, it's not only going to affect the steel on the tracking system. Of course, that's the main issue on the tracking system, but then you need to make sure that or your slew drive or electromechanical components are also able to withstand those conditions. So on the steel part, it depends. There are several solutions in the market, and we can design for really harsh environments, C5, CX, to make sure that you have 25 years of warranty, 30 years of warranty with a big layer of galvanizing coating, or with specific alloys such as Magnelis from ArcelorMittal or Postmac from POSCO. It's important, and it's critical on this galvanizing, is that we've seen in some projects that we've been requested to increase the galvanizing thickness out of and provide values that are not reasonable. For example, in a 1 millimeter thick or 1.2 millimeter thick steel, you cannot use 200 microns coating, because what's going to happen is you're going to submerge that into the galvanizing, and then once you take it out, that layer of coating, it's going to peel off. So it doesn't matter if you have 200 microns of coating, if that, as soon as you deliver it to site, it's going to peel, and you're going to have the steel exposed. And that's for one point that's critical, that we tried for the EPCs and developers to understand, that asking for high values of galvanizing coating, it's not going to help you if the steel is not able to absorb that quantity of galvanizing. And there's always alternatives, such as with the magnesium POSCO, to comply with those corrosion ambient conditions. And again, as important to prepare for the corrosion, it's important to prepare for the abrasion, and it's critical to understand. There's studies that have been done with actual test site that show that the difference between corrosion and abrasion, when you consider abrasion, you have either 2 to 4 times more corrosion when you consider that abrasion, because that's going to take out the surface, and then you have the corrosion on the inner layers of the steel. Those are at least the 2 critical points that you take into account. There's a maximum thickness of galvanizing, and that there are other solutions to use in the tracking system to other than hot dip galvanizing.
Thank you very much, Alvaro. Manish?
Yeah, it's a very, I would say, very, very important important discussion point in our technical meetings, and I have been learning from my colleagues in the technical department, and what has the phenomena that we have observed in the recent past. While aqua power, we have used all kind of steels in our projects. There are some special steels Alvaro mentioned, which are Magnelis, Postmac, which are nothing but an alloy of zinc, aluminum, and manganese. So these special steels are having better properties against corrosion, significantly better. It's just that they are still new. It's a technology with very few limited players around the world. You need to be watchful of the overall impact on the cost, and the costs are going down. So our experience is, go for special steels if you have higher corrosion requirement in a site, because you can definitely manage your weight of the tracker, and they can be more optimum in the overall cost structure. The second point on the abrasion, rightly mentioned by Alvaro, we have faced, there are some test studies that we have seen that the impact of abrasion on the rate of corrosion really gets accelerated, maybe 3 to 4 times or 5 times. And this is one area where you will not find any specific international code that will guide you, but people are relying more and more on the laboratory tests or the field tests that have been conducted with 2 years, 3 years, 4 years of data range available with you. So our take is corrosion is a very, very important phenomena. When you decide a tracker, the coating, it must be carefully analyzed. And a lot of it depends upon the readiness and the ecosystem that you have in that particular region. If they don't have right galvanizing facilities, you should not be going ahead with HDG solution. Two, when you go for hot dip galvanized or pre-galvanized solution, when they cut and punch the holes and all, they are exposed to further corrosion, and you need to make a lot of touch-up, which adds to the cost. And especially in the Middle East area, where the labor cost is extremely high, we should avoid such pitfalls. And last but not the least, go a little conservative. Many a times what happens, the tracker supplier will try to conduct a study, and they will, when the price gets locked, the tracker supplier always comes back and say that this is the corrosion category of this project. And as a developer, you should always go one step higher in the corrosion category, being a little conservative approach, because the corrosion environment tends to change over a life of 25 years. It will not remain same, it will not remain static. So whenever you plan your tracker corrosion protection system, go a little bit conservative on the corrosion category of the project.
Thank you very much, guys. Thank you very much. We have about 25 minutes left, and I've been asking some questions from the audience, but in order to accommodate more, I'm going to ask you to go to the point as much as you guys can, even though I still want to encourage, you to keep answering the questions and, of course, adding points on top of, what the other person said. The next question is about how strong winds influence the design of PV systems, and what is the effect of the distance between modules specific. So this has got to do with the design of the modules. So Alvaro, you want to start?
Sure. So I think that we briefly discussed at the beginning, the wind speed has a greater effect on 2P tracking system than what it does on 1P tracking systems. Of course, because of the surface that you have exposed to the wind on the tracking system. And then the pitch or the distance between the trackers also has an effect. The higher the pitch, the more space you're giving to the wind to go back and to impact the next tracking system. So you need always on projects to strike a balance. If you give a high pitch and you're using 2P tracking system, the cost of the tracking system will increase exponentially, because you're going to need to reinforce that tracking system. You need to reinforce the torque tube, the piles, to make sure that you withstand those winds that will be reacting with the tracking system. So straight to the point, that's the effect. You'll need to reinforce bigger in the 2P than in the 1P, and the bigger the pitch that you have, the more that you need to reinforce the tracking systems.
Excellent. Do you have anything to add, Manish? Yeah, go right ahead.
No, I think yes, is comprehensively covered this.
Excellent, thank you. So one of the questions that I actually left behind by mistake, what are the key wind mitigation components that you need to look for in a tracker when selecting it? Alvaro.
Okay. I've also seen that there was a question if PVH uses dampers. We don't need dampers on the tracking system, and that's specific to our tracking system. Other tracker suppliers might need to use it, but on our case, this is based on the results that we have from the 3D elastic test and the static wind tunnel testing, and the items that we use to understand or to go to stow or to mitigate the wind is the ultrasonic. We have ultrasonic anemometers that we place carefully around the site, depending on the shape of the site, depending on what's the layout that we have on the site, to make sure that we detect beforehand that wind event. And also we have predictive measures that would sense if there's a wind event that might come, and then the tracking system would be able to go to stow. before that maximum wind speed is reached at that site.
Yeah, thank you, Alvaro. There are some questions from the audience about that too. Manish, anytime you want, go right ahead.
No, I just want that let's pick up 2 or 3 questions from the audience, and I'm sure there are many questions being asked. If you can pick up 2 or 3 and let's try to answer them.
All right, the biggest question that I have, and I was saving it, is the soiling side of things, guys. There is so many questions about soiling, about cleaning. How do you solve it? What is the best technique, dry or wet? What is the impact of anti-reflect coating? Lessons learned in PV design to tackle cleaning. Here particularly was about bifacial modules, but I'll ask you about bifacial later as well. The impact on inverters, modules, trackers. Then someone in Saudi says that he's working in a plant in Saudi. There is a constant problem of fine dust accumulating in the panels, and they have to be regularly washed every few days, which makes it a lot of water, and it defeats the environmental objective for using PV systems. Is there a solution with a practical and environmentally friendly? So lots and lots of questions. I mean, literally one just sent just now from YouTube that says lessons learned in PV design to tackle cleaning of bifacial modules. So why don't I open the topic? You know, clearly it's a hot topic. So I open the topic to the two of you guys so that you can go into detail if you like. Manish, why don't you start? Because this is more a contextual thing. We can get into trackers specifically. Go right ahead.
Let me try to cover some of those questions. Some people ask, how do you measure swelling loss? So there are equipments, there are tools. We have Dust IQ these days available from KIP and Zonan, which helps you measure. It's a reference cell. So you clean that cell with the same frequency as you clean your plants, versus there's another cell that gets cleaned regularly. And the loss between the two is representative of your swelling loss. 2, how are we managing the swelling loss in our plants? Some of our plants are having a manual mechanism where we clean all the panels using earth mover along with some brush mechanism, and we adopt both dry cleaning as well as wet cleaning approach. Wet cleaning is less frequent. We also have now all our recent projects, one of them being recently commissioned in Oman, that is based on entirely on 100% robotic cleaning technology. And to answer to the question that how you are adopting environmental friendly approach, this is the environment friendly approach where we are not using any water for the cleaning purposes. The third very recent phenomena that we have adopted across our fleet, more than 1.5 gigawatt right now, is we are bringing in AI into our SCADA system. We are implementing some latest niche data analytics tool, and through the AI, we get feeds that which area is suffering higher swelling losses, and it helps us in optimizing the cleaning cost. So we know exactly in our whole plant which areas are suffering more cleaning losses, and that's how we direct our attention and our efforts to those areas more frequently than other areas. That's one way of managing the swelling loss and keeping your costs low. The second thing is the right mechanism. When you choose a robotic cleaning technology, you must pay special attention to the cloth which they are using. What kind of material is this which is cleaning your robotic panel? Is it compatible with the ARC coating? So when we select any robotic technology, we always ensure that we have an NOC from the module supplier so that there is a confirmation from him that this technology is not going to impact the ARC coating. We also get an NOC from the tracker supplier, which says that this robot is compatible with the tracker. And third, which is very, very important, is the SCADA communication between robotic technology and your plant SCADA. Is it talking to your SCADA frequently on a real-time basis so that if there are any events, the robotic your robot can talk to the SCADA and take commands and give alarms. So by using these various combinations, we manage all the cleaning losses across our fleet. Alan, let me know if there is any question that remain unanswered, and I'll try to attempt, and then.
Excellent. Yeah, we still have 15 minutes. Go right ahead, Alvaro. Do you want to add here?
Not much to add, only that as tracker supplier, we work with several robotic vendors to make sure that they are fully compatible with the tracking system. We also offer our own solution in case the client doesn't want any of this other solution proposed. On the tracking system, it's not that critical to have the integration. It's easy to implement the robotic solution. The difficult part would be to integrate with the module suppliers. We usually see a lot of pressure from EPCs trying to push for the NOC from the tracking system. It's not that difficult to have that NOC issued. The main limitation is going to come from the module supplier. If the module supplier accepts the pressure and the weight of the robotic cleaning solution, the tracking system, for the tracking system, the weight of the robot is minimal compared to the wind reaction on the tracker. So there's not an additional design that you will need to do on the tracking system to make sure that it's compatible.
Excellent. Thank you very much for those additions. So the next question that I'll ask, also coming from the audience, if I may, is regarding whether bifacial PV structures projects make sense in the desert, considering that, obviously the bifaciality and the elevators would be pretty good, but what to take into consideration. So the question is, how have bifacial PV module sites performed in desert regions with the higher operating temperatures, additional soiling, and other factors? So who wants to begin with that?
Let me attempt, Bella.
Yeah.
So bifacial is the latest technology, and why it has been adopted more and more by the developers across the world is because of the fact that the price of bifacial panels versus the price of monofacial panels, the gap has been reduced significantly. Now the gap is in the range which makes bifacial more value adding compared to monofacial. And if you have higher albedo, typically in the Middle East area, you have albedo ranging from anywhere between 28% to 38% or 40%. So the higher the albedo, the higher will be the backside gain from these modules. And usually those gains, they are higher in value compared to the cost that you are paying for the bifacial panel. That defines the value proposition. In terms of the losses, there is no way right now, which we are aware of, how to clean the backside of the bifacial panels. But based on some of the tests and some of the experiments that we have conducted, we reached a conclusion that it does not require frequent cleaning the way you need to clean the top side, because the dust doesn't stay there. And right now, there is a consensus amongst our technical team that bifacial panels on the backside do not need any cleaning. However, we will keep observing it. We will keep measuring the losses. And we are very hopeful that over the next few years, the robotic cleaning industry will come up with some mechanism how to clean from the backside also efficiently in a cost optimum manner.
And without using much water. You guys have your work
without
cut out for you.
using much water. Yes.
And if it's cheap, then great.
and plus the impact of soiling on the backside is significantly lower, because you get anywhere between 8 to 10% of your gain from the backside. So a 1% soiling loss on the backside is impacting on very less generation, because it's only impacting the 8% of the generation. So it's 1% of 8%.
What's true is the albedo must be really high and with when there is sand. It's pretty good, or does it change a lot?
30 to 36% is what we have observed easily.
Okay. Alvaro, do you want to add anything here? Or shall I just move along? There's a lot of questions about row, like stowing positions. Okay. You guys take a look at the questions if you want to answer them specifically. Let me just ask this one because it's been asked several times and repeatedly. So obviously there is interest as well, not as much as the cleaning and soiling side, but there's a couple of questions about minimum stow wind speed. And one of the questions that is repeated several times is, what is a typical wind, at what typical wind speed do you store the rows so that wind speed is deemed satisfactory? Should a road actuator break down and get stuck in the tilted position, for example, at a critical 10 degrees, 40 degrees? in South Africa have seen some of the large installations rolled up. So it's about stowing positions and wind braking mechanisms. Alvaro?
Okay. Didn't understand the second part, but on our case, it depends on the tracking system. 1P tracking system doesn't stow at the same wind speed as a 2P or 3H tracking system. And that's implicit on the design. So if you need to change it, the price of the tracking system is going to increase exponentially. Typically, a 1P tracking system stows at 16 meters per second, depends on the tracker supplier. We do stow at 16 meters per second. And sorry, 2P tracking system, we stow at 16 meters per second. And a 1P, we stow at 20 meters per second.
Thank you very much. In addition from you, Manish?
The stowing strategy is different for different tracker supplier, and it all depends upon the very specific design. We have seen some tracker suppliers stowing at even 50 degrees, some stowing at 30 degrees. What is more important is the coordination between your stow strategy and at what wind speed you give the stow command. So all trackers typically have an operational wind speed around 20 meters per second, or some of them have 15 meters per second. Based on this operational wind speed, they trigger the stow command, maybe 2 or 3 or 4 meters lower than that, because the wind takes time to build up. So the moment your weather station system senses a high wind speed, there is a defined level at which the stow command gets generated, and your tracker start moving into the stow position. So a lot of it depends upon your entire wind stowing strategy, which is the angle at which you are going to stow, at what point in time you are going to give the stow command, and how much time the tracker takes from the stow command to come to the stowing position.
Okay, I'd like to ask you a question, Manish. Actually, there is made up of a bunch of questions that people have sent through about temperature and managing that. And Alvaro, if of course you can add if you like in here anytime, but also if you take a look at the questions and see which you want to answer next, I will ask you the same, Manish, after. There is a bunch of people here about asking about issues with high temperature. So one here asks, have you had problems, failures of connectors in high temperature locations? Someone will ask, I'd like to know how the bus cable must be installed in desert areas. This can be handled by the air through air cable management, like in the US, or must it be buried? What are the advantages and cons of this? Also answering to this sort of topic. And someone else asks here, at what extent the temperature can affect PV systems and how can it be minimized? This is just a selection of questions. Yeah.
Now, let me try to. I think I'll go in terms of the priority that we have seen. The major impact that we have observed is in your inverter station. When you face very high ambient temperature conditions, which are coupled with internal heat generated by equipments like inverters. So your heat dissipation design needs to be carefully analyzed. I touched this before as well. Why? Because one, your inverters tend to derate beyond a certain temperature, typically 50 degrees of ambient. How much is the duration? If you continue to operate them under very high temperature conditions, you will get lesser output from the plant. So there is a direct impact on your energy generation. Two, there can be risk of fires in certain cases. If the heat is not dissipated well, it will build up, and there can be instances around the fire which create issues on your insurance part, and then blame game starts. Third, we have not observed any impact on the contact. There was a question around, have we seen any contact, any issues on the connections? We have not seen any such issue. Third was around the design, whether we lay cables under the ground or we take them above the ground. The practice in Middle East is to lay cables under the ground. If you have to go above the ground, it requires special approval. We have seen it happening in Dubai in one of the plant, but in Saudi predominantly they are all buried under the ground. The practice does not allow you to take them hanging or through a cable tray mechanism.
Excellent, thank you. Anything to add here, Alvaro, or any questions specifically you want to answer?
Nothing that I have seen.
Have you checked any of the questions?
I've checked the panel questions. There's probably they're more intended for manage rather than for the tracking.
Let me try to take few questions and I'll go one by one. The role of machine learning in PV fault, the last one I could see on the table. There, it is gaining momentum. A lot can be extracted from your running PV plants with robust data analytics and machine learning algorithms. We have successfully implemented one such where we reduced our cleaning cost. More algorithms are currently under working, and going forward we have planned that majority of our plants or all the PV fleet will be utilizing these latest machine learning technologies, and we'll try to extract the maximum value out of it. Now, one problem I'm facing the moment I'm reading, the window is moving up. Just allow me, guys, 1 second. Let me read another question.
Yeah, it's complicated, but if you want, I can like put in the middle like a question for Alvaro that I have anyway. 3D backtracking algorithms can prevent shade-induced generation losses from uneven terrain to maximize power plant generation. Is that correct? Can it be used in PV projects?
Yes, it's correct. The only caveat which I want to give is our suppliers typically tend to overstate the benefits because they are on the supply side. What we have observed, the gain is very high in undulating terrains. The more the undulations, the more you will see the gain from such backtracking algorithm, because they typically tend to reduce your shading losses and the mismatch losses. The second phenomena that we have observed is even with the flat terrain, you will have possibility of gain in the early morning and the late hours when the shading is extremely high. So these backtracking algorithms are now in vogue. They are now in fashion. All the tracker suppliers, they have their own code names, but the principle behind all those technologies is same. It requires, it's basically on each tracker by tracker coordinate, it goes into a system, and there is a angle that is defined for each tracker rather than making all the trackers going into the following the same command. So each tracker will have a different angle at a different point in time. It need not be the same all across your plant, and that's how they are building up additional value.
Excellent, thank you. Alvaro, do you want to add there?
Yeah, sure. I mean, that's correct. It's better to be heard directly from the developer rather than from the tracking system supplier. But yes, I mean, it depends on the algorithm that you have, that you will have this gain. I mean, in the end, this gain is a reduction of the losses. I mean, of course, you cannot gather more energy than the one that is getting to the plant. So when you have undulations, what you're trying to tackle is to make sure that the tracking system reacts as if you have a completely flat terrain and you avoid the shadows in between the tracking systems. There's different solutions out there. Of course, we do think that the approach that we've taken is the most efficient, and we take the individual coordinate of every single tracker at the site. So in the end, the information that you need to perform the backtracking, it's already there. You know the position of the sun, you know the position of every single tracking system. If you have that information and precise, you're able to do a backtracking that completely avoids the shading. So that also takes into account if you have the rows in different slopes. If you have a row that has a counter slope, you won't be casting a shadow to the next tracking system, which is not something that anybody can do, because it depends on the methodology that you have to measure. If you're using PV solar panels to measure if you're getting that shadow, you will only be getting half of the information, and you cannot read that information on the edge of the tracking system. And in our case, we take the complete information of the site to make sure that this 3D backtracking is performed as precise as possible. We do even have the option, for example, if you're using half-cut cells, to backtrack, to do this backtracking and to only cast shadow on the top or on the bottom portion of the PV panel. So you generate with the top half. So, and that's possible because we take this information and we have our own controller with our own algorithm. So different technologies, of course, we will push our 3D backtracking solution as the best one to try to minimize the losses on the backtracking.
Okay, if I
One
may.
request, Alvaro.
Go on.
When you say your own controller, we are developer and we are always very, very cost conscious. I think you should quickly try to align with with the top string suppliers, string inverter suppliers, and see that you use their controller for your purpose, and you take out this cost from the tracker, please. We badly need this.
Correct. Correct.
You've got your request.
Actually, we're already doing it, but of course there's a few challenges on integrating it, because even if you try to take out the controller and put it on the inverter, you always need a small component to have in the tracking system. Plus, you need the cabling. So we're trying to see the solution to have that as a proper cost reduction, not to give a half-baked solution. But it's on the way. We will probably get back to you, Manish, on this.
Excellent. I like to see this. Okay, because we have to go just 2 more things. Okay, one is very simple, don't need a lot of explanation, just the basics. Framed versus frameless modules for this specific desert conditions. What is your pick? And the other one's about climate change. So why don't you answer that first, and then I'll ask you the last question.
Okay. As a developer, my pick would be framed module, and a request to the module manufacturers that how can they come up with more innovative frame designs where the cost of the aluminum gets reduced and it still provides the same strength as well as a reasonable area on which our robots can move. While the negative side of the frame module is they are a little costlier compared to frameless.
Excellent, thank
Alvaro.
you. Manish, Alvaro?
So on regards to the tracking system, of course, the frame module would be more robust. I'm not sure what would be the cost implications on the project, but to us, we can integrate both of the solutions effectively and make sure that you don't have related problems or any problem at the site. We actually, in the project that we've supplied in Dubai, which is in 1 gigawatt in desert conditions, it's completely frameless module and it's working. So in the end, it's how you anchor that module that's going to define if it's robust or not in the end. And then you need to take into account the cost implications, which I'm not sure what's the difference. That would be on more on aqua power side.
See, handling can be a challenge. With frame module, the handling is better. The breakages are significantly lower, and the strength ensures that your micro cracks are in control.
Correct.
Excellent.
Plus the robotic cleaning integration. Frameless modules, it's a lot more difficult to have a proper robotic cleaning solution that's going to be effectively cleaning it.
Excellent, thank you guys. So framed all the way, guys, but just making sure you use the calculator. And for the module manufacturers out there, work out for you. Maybe you use less steel in the production of the panels and give easier access to the cleaning. And just the last question, guys. Is there a need to continuously revisit the statistics of wind and solar potentials in the different regions due to the impact of climate change and its consequences? How are you preparing for climate change? How are the standards preparing for climate change, especially in the wind speeds? Don't know who wants to take this question. It's a little bit out there, but I think it's important because we need to prepare, because not only do the plants need to be designed differently, also the plants that are there, they need to last for several decades. So Alvaro?
Okay, Alvaro. I'm saying it's too technical. I would like to answer it based on my logic and what I have observed, and I may not be absolutely true in my response, but what I have observed, the temperature is one external phenomena that we have seen changing. But when you rely on a data source which is based on the last 25 years of experience, the chances of that number going significantly higher are much less. And when it comes to wind speed, I don't think that the wind speed are likely to change because they are governed by local codes which have been formulated after many years of experience, and they typically tend to have internal inbuilt factor of safeties. So if the code says X wind speed, the actual which you realize on the ground is always lower than that. So when you design a system, there is multiple layers of factor of safety already inbuilt. So I don't see this as a big risk during the lifetime of the solar PV plant until Alvaro has some expert views and a contrary opinion. Alvaro.
No, properly explained, Manish. Actually, the data that we've gathered and the analysis that it's done on every single project to make sure that it's complying with the requirements of the site, it's taking into account the past years. It's so even if climate change changes a lot the conditions at the site, there you won't see a massive change on wind speed. You won't see, maybe you can see a big change on the heat at site, on the temperature that you might have at site. So specifically on desert conditions might increase a little bit. But once you've reached a certain temperature, the protections that you're taking into account have a wider tolerance. It might be even more difficult to protect the tracking system in really cold environments, at least on the electromechanical side, especially on the battery side. But once you've designed the battery to be able to operate at 50 degrees, doesn't matter if it's 50 degrees or it's 60 degrees, it's going to be able to operate in those conditions.
Excellent. Manish,
I'll just pick one question. I'll just pick one question. Someone has asked on the backtracking philosophy that if they are at different positions, that how is it impacting the robots during cleaning? So my response is that it will not impact the robotic cleaning because the robot are designed to work up to certain maximum angle. And when you have this store strategy in place, if there is any angle breaching that limit, you can always take care in your SCADA.
Excellent, thank you. There is one that you wanted to answer, right? Alvaro says, considering the backtracking philosophy explained, we understand that tables might be at different positions. However, will this affect the movement of robots during cleaning?
Yeah, that's more or less in the same question that Manish was answering. The robots are designed to work at a certain angle of the tracking system. So on the tracking system, you'll have the operation mode, the backtrack, the stowing angle mode, and then the cleaning mode. Depends on the robotic cleaning solution. They need 5 degrees, they need 10 degrees, 0 degrees. Whenever there's a wind event, that signal would be also sent to the robotic cleaning solution, so they can either stop on top of the tracking system and remain there while they're in stow position, or they can try to reach the docking station. And once it reaches, the tracker can go to stow position. So it depends. Robot has a complex procedure to react to these wind alarms.
And there's one very powerful question. I think it's worth taking it. It is by Abdullah Abdul Rahman. He's asking, have you ever considered using polymer matrix composites instead of conventional alloys or steel? And it's a question in my mind as well, Alvaro, because I remember 3 years back, I did a lot of comparative between steel and these composite alloys, mainly HDPE based substances. And what we reached a conclusion is, one, the cost was very high compared to steel, and two, the adoption rate we could not see. While technically it would have justified that it makes sense, but why it could not be used by players like you is something which I would also want to know.
Thank you very much, Manish, and thank you very much, Alvaro.
Well,
it's been
in the end, the limitations are the ones that you said.
I think last question, Bell, and I know we are running out of time, but that's
okay. I don't mind. You guys go. You're the ones that have to go. Go ahead.
Last answer is going to be short. So in the end, there's two main drivers for this, which is the cost of implementing it and how can we escalate it? Is it possible to use the infrastructure that we have to supply with this polymers? And so far, it's not an easy task. It won't be done easily. It would take time. Of course, it would make sense to study it, but then the price still doesn't make sense. It still is too high compared to using a conventional steel. I mean, seeing the trend of the steel that keeps increasing, maybe at some point in the near future, it would make sense to consider it. But so far, we're still going to use steel on the tracking system.
Thank you, Alvaro. And I don't know, Bella, how are we keeping up with the time? But
we're 10
we may
minutes
not
fast, but hey, who's checking? Thank you very much, Manish, and thank you very much, Alvaro. You guys, you can tell that they enjoy their jobs so much. You know, they're willing to just chat about backtracking, about frame versus frameless PV. So thank you very much for being here and sharing all of this wealth of knowledge with us. There has been a lot of interest from the attendee sides. Thank you very much for being here as well. You know, we highly appreciate the fact that you keep guys coming back to these sessions. So thank you for that. And I will catch up with you guys and see you in a few months, hopefully. Thank you very much.